A drone that carries and deploys 100 other drones mid-flight. A robot that patrols streets on land and through water. A quantum computer that finishes in seconds what a supercomputer would need 6 billion years to complete. None of this is a concept. All of it exists right now. The flying aircraft carrier. The Guishan SSUAV is not a drone. It is a flying aircraft carrier. Developed by the Aviation Industry Corporation of China, this machine weighs 16 tons, carries a 25-meter wingspan, and can transport up to 6 tons of payload over a range of 7,000 kilometers while flying at altitudes above 15,000 meters for 12 continuous hours. What makes it genuinely unprecedented is the modular mission bay built into its fuselage, specifically engineered to deploy swarms of smaller drones mid-flight. Not one or two, over 100. Each launch drone operates as part of an AI-coordinated swarm, capable of saturating air defense systems through simultaneous, multi-directional attacks while sharing real-time battlefield data between units. The strategic implication is significant. Traditional air power requires individual aircraft, individual pilots, individual targets. The Guishan creates a single platform that controls a distributed intelligent network of weapons across a wide area at the same time. China is not building bigger drones. It is building complete aerial ecosystems that operate autonomously. That is a completely different category from anything that came before. The spherical police robot that swims. The RTG, developed by Logan Technology, is a fully autonomous spherical police robot already patrolling streets in Chinese cities, including Wenzhou. It weighs 125 kilograms, reaches speeds of 35 kilometers per hour, and operates across land, mud, rivers, and terrain that would stop any conventional wheeled vehicle. The spherical design is deliberate. It cannot be overturned or pinned, and its gyroscopic self-stabilization system keeps it moving over any surface. Its capabilities go well beyond mobility. Facial recognition powered by onboard AI identifiers wanted individuals in real time by cross-referencing live camera feeds against police databases. When a threat is detected, the robot can respond autonomously, deploying nets to restrain suspects, dispersing tear gas, emitting crowd control sound waves, and absorbing physical impacts of up to 4 tons through its resistant casing. It is already working alongside human officers on 24-hour patrols in high-risk commercial areas. Not in trials, in real deployment. The question this raises, a machine that identifies, pursues, and acts on its own judgment in public, is something most countries are still debating. China already deployed it, the flying taxi that is already commercial. Most countries are still working on regulations for electric air taxis. China skipped that phase. The EHang 216S, an electric vertical takeoff and landing aircraft, entered full commercial passenger service in Guangzhou and Hefei in 2025 after more than 10,000 test flights. Each trip runs approximately 21 minutes at 80 miles per hour, with a 19-mile range. No pilot required, no emissions, no traffic. EHang has secured orders from at least 7 countries with over 1,200 units on order globally. Meanwhile, on the ground, autonomous robo-taxi operations across Shenzhen, Beijing, and Wuhan have logged over 7 million passenger rides compared to Waymo's approximately 250,000 weekly trips in the United States. Chinese robo-taxi fares are about 3 times cheaper than conventional taxis, and no serious accidents have been recorded across more than 20 million miles of operation. What China has built is not a collection of separate experiments. It is a vertically integrated 3-dimensional mobility network, vehicles in the air and on the ground running on shared AI infrastructure at real scale in real cities. That combination does not exist anywhere else. The island building machine.
What if I told you that China has the ability to create artificial islands out of nothing? The Magic Island Maker is exactly that, a dredging and marine construction platform that can transform the ocean floor into habitable land in a matter of months. This floating megastructure combines precision suction technology with ultra-high power pumping systems capable of moving millions of cubic meters of sediment. Its sophisticated GPS positioning system guarantees millimetric accuracy in the deposition of materials, creating stable land formations designed to withstand storms and extreme ocean conditions. The process is fascinating. Powerful pumps extract sand and sediment from the seabed.
The Magic Island Maker is a dredging and marine construction platform capable of transforming ocean floor into habitable land in months. Its systems combine precision suction technology with ultra-high power pumps moving millions of cubic meters of sediment through giant pipes to exact locations, where GPS positioning ensures extremely high accuracy in material placement. Automatic compaction systems ensure structural stability as the land forms layer by layer. Sensors monitor the entire construction process in real time. The result is stable land formations engineered to withstand storms and extreme ocean conditions, built entirely from seabed sediment. China has used this technology to create ports, research installations, and territorial extensions across contested maritime zones. These are not reclaimed areas. These are new land masses built from open water. The maps of the South China Sea have physically changed because of this. The quantum computer, 1 quadrillion times faster.
Quantum computers are the reflexes, and encrypted intercontinental communication is the nervous system. China is investing heavily in all three. Zhuangzi G3, or Zhuangzi 3.0, is a 105-qubit superconducting quantum computer developed by the University of Science and Technology of China. In a test with an 83-qubit random circuit, it completed a task in hundreds of seconds, something the world's top supercomputer, Frontier, would take 6.4 billion years to process.
Zhuangzi 3.0 is a 105-qubit superconducting quantum computer developed at the University of Science and Technology of China. In a benchmark involving an 83-qubit random circuit, it completed a task in hundreds of seconds. The world's most powerful classical supercomputer, Frontier, would require 6.4 billion years to process the same computation. That is roughly 1 quadrillion times faster. Compared to Google's most advanced quantum system, it is about 1 million times faster on similar tasks. China is pairing this with an intercontinental encrypted communication network combining a 3,000-mile terrestrial fiber grid with satellite links designed to move secure data across continents almost instantly. The combination of extreme processing speed and secure communication creates a completely new level of strategic advantage. A system that can solve problems no classical computer can handle and transmit results instantly creates a form of information dominance that did not exist before. Thorium reactors in the desert.
Thorium-based nuclear power using molten salt reactors that don't require water cooling. Notably, this choice isn't from industrialized hubs like Shanghai or Shenzhen, but the arid heart of the Gobi Desert. The TMS RLF-1 reactor is the first testbed in China's thorium strategy. At just 2 megawatts, seemingly small, its significance lies not in scale, but in its water-free operation.
In the middle of the Gobi Desert, China is operating a nuclear reactor that requires no water. The TMSRLF-1 is a thorium-based molten salt reactor using air cooling, built where traditional nuclear plants cannot operate. Thorium is 3 to 4 times more abundant in Earth's crust than uranium. It produces waste with a radioactive lifespan of 300 to 500 years instead of tens of thousands. It is harder to weaponize and can be deployed in compact modular units across remote and water-scarce regions. China's 2029 roadmap includes a 10-megawatt electrical thorium reactor powering tens of thousands of homes. By 2035, with a 200-gigawatt nuclear expansion target, analysts expect dozens of these installations across the country. The AY that runs on A gaming PC DeepSeek R1 achieved around 80% on standard mathematical reasoning benchmarks, nearly matching top Olympiad-level students while reducing operating costs by up to 95% compared to similar American models. QWQ32B pushed that efficiency further, a model that can run on consumer GPU systems at around 20 cents per million requests. Small developers can now access reasoning capabilities that previously required large-scale infrastructure. Behind both sits the Ascend 910B, a Huawei-developed AI chip built on a 7-nanometer process, reportedly matching NVIDIA H100-level performance, despite export restrictions and sanctions. The message is clear. China is not relying on Western supply chains. It is building its own parallel ecosystem. A flying aircraft carrier deploying drone swarms. A spherical robot that swims and identifies faces. Commercial air taxis already carrying passengers. An island-building machine reshaping geography. A quantum computer a quadrillion times faster than anything else. A nuclear reactor in a desert that needs no water. an AY system that runs on a gaming PC at extremely low cost. Every single one of these exists and is operational in 2026. Drop a comment telling us which one changes the world first. Check the end screen for more technology breakdowns waiting for you.